Hello to everyone. Today we'll try to discuss about the geographical information systems topology. This is Dr. Shobha Rani working as a professor in the department of CSE of RMDEC. The topology, data input and topology are very important in the geographical information system because we are going to draw the various types of the data or we are going to club the various data of data by applying the topic called as a topology. That's what we are going to see that one. See, analog data, analog versus digital data. We know what is meant by analog data as well as digital data. We know analog data as well as digital data. Analog data is a includes a maps. What you are going to do, draw in the papers, the maps, tables, or statistics, whatever you are going to do it, and those analog data will be converted into a digital data. Digital data nowadays normally we are not going to do normally in the form of an analog data. Also we are going to make use of the systems, drawing of the everything. We'll try to make it as in the form of a hard copy or a soft copy. That soft copy will be converted in the form of a map data or in the form of a aerial photographs or satellite imaginary. Such data loggers only, and then the GPS are all available in the digital formats. How you are going to do the data encoding? The data encoding is getting the data into the computer. That means it is a process that is fundamental to almost all every GIS. For example, an archaeologist may encode the aerial photographs of the ancient domains to integrate with newly collected field. That is also one of the data encoding. Or if, for example, if you wanted to give an outline for the new buildings and plot this on an existing topographic area, that is also one of the data encoding. Or if you wanted to get this, you are going to sense the data and where it changes the habitats, that is also. So we can keep on talking about the various types of the data, how the data will be encoded in the form of the digitalized data is nothing but only you are going to call it as a digital data. Excuse me. Once in the GIS, data almost always needed to be corrected and manipulated. See, always you try to get in the GIS only in the form of a raw data. The raw data will never give you the information. The raw data can be refined, and the raw data can be manipulated in a few data you will insert, few data you delete, few data you modify. You try to make the heterogeneous data, and then you are going to give a structure for that one. That data only you are going to call that one called as an information, and from the information you will be able to gain the logic. Okay, for this particular data, by making use of the topology, you try to make use of the projections. Now we'll try to see the how the various types of the projections will be done. Okay, the one of the best example for the a topology or a digital data is the scanner. Normal scanner, what we are going to do is only the scanner converts the paper maps into the digital format. It will captures the cells. You know what is meant when you draw a table, the all the four borders of a table, one you are going to call that one called as the cells, and you know the pixels, the points inside that cells we will try to call it as pictures, and it will produces the automatic image. Okay, next one is a time paper maps are not easily available in a form that can be readily used. Now you are going to make use of the old conventional models. We have to resort to the maps, and these paper maps have to be first converted into a digital form by making use of the systems. And this is the critical. The world lying all the physical maps should be converted into a digital maps by making use of the computer. Few are very easy, few you need a very tedious work of converting an analog document to the a digital document. Okay, so this technology almost all is used for the analog to the digital by making use of the scanners. You can in the scanners we will try to give three important points. One is nothing but the making use of your cells, making use of your pixels, making use of your grids, making use of your tuples and okay, these are all the major type of the scanners. See, this is a mechanical scanner. You will have the analog to digital that has been covered, and you have the drum, and you are going to get the digital output. Second one is nothing but the you have a map on the image CRT, electronic beam will be there. Okay, digital output will be there. So map on the image you have on CCD camera will be captured here. The CCD camera. you are going to the image will be there, the image will be converted from analog to digital, and the digital output way you are going to get the clarification. And then the linear ccd is there. Linear ccd is also from the analog to every all these phone scanners, you are going to convert a clear capture of the image only, we are going to call it as a scanners, ccd camera or the the scanner. The CCD scanner, it will also will give the digital output. Camera also will everywhere. If you observe in these four figures, it will give the digital output, but everywhere it will be converted into an analog to digital. But in few areas, it will be converted by making use of the CRT, and a few other areas it is making use of the CCD camera, and then next one is the CCD scanner. Okay, these are all the various types of the accuracies. See, for it is a mechanical scanner, the accuracy will be very high. Okay, resolution also will be very high. Cost is also very high. If it is a video camera, the accuracy is low and it is the cost is cheap, but resolution is also low. So we cannot you make use of it. If it is a clear camera capture camera, also it is a medium accuracy. It is a cheap for the low resolution, high for the high resolution. And then the CCD scanner, the accuracy will be high, the cost will be high. Okay, and it is a resolution also will be depends upon their areas of the organization or the requirement of the organization. They will try to apply it for whether they wanted to buy the CC, they wanted to make use of the CCD scanners, or when they wanted to make use of the CCD cameras or video cameras. Okay, working of the CCD scanner, it has been seen here. See, light capturing CCD elements, and then converter from analog to digital converter, and then we have the WebGL, just like your WebGL, you have the RGB, where three types of the colors coated in CCD chip, that is red, green, blue coated in the chips, and we have the lenses and the mirror lights resource. That means first you have the original copy that has been placed on this, and then it is going to make a scanner of call it. It will create a mirror copy, and then after mirror copy with the lens, it will you will be able to capture it, the size of it. When once the mirror copy has been completed, by making use of the lens only, you will be able to get the size of the original spaces. Okay, that's what they wanted to explain this one. Okay, the scanner head contains either a charged coupled device or a sensor or a contact image. Contact image sensors, you will have that. Charged CCDs will be there, or it consists of a number of photosensitive cells or a pixels packed together on a chip. These are all the various, the most advanced large format scanners uses CCDs with 8,000 pixels and all. Okay, the pixels will be transfers a gray tone values. These are all the various types of the calculations how the digital scanner will work it out. See, the pixel transfers a gray tone values. That means in the corner of the each cell, or maybe in the points and all, there will be a gray tone values. Those will be converted in the form of RGB only. So you will have the 0 to 55 to white color will be there. So it will be of 256 colors. That means each and every corner of that particular cell, you are going to convert into a gray tone value. You just measure it from the cell. For example, in your zero x-axis, y-axis, from zero, no, they will start measuring that one. The software interprets the values in terms of 0 or 1. As the head moves ahead, it scans the image in a tiny strips, and the sensor continues. This type of scanning, the software running the scanner purses together with the information from the sensor, is nothing but, you try to call it as called as a one pass scanning. Okay, so as we have seen already, this is called as a charge coupled device. In the three colors, you are going to apply the charge coupled device in a monochrome value, by making use of the monochrome value. You know, exactly you the x-axis and y-axis where the point is going to join in on. By in this color, you are going to construct a red color, green color, and blue color, and with the 24 RGB, you are going to pixels. You are going to do this one. Here, handled scanner is there, where the small logos or signatures, if you wanted to make use of it, normally they'll try to make use of the handled scanners. Okay, this is nothing but the flatbed scanner, where you are going to large maps or the top sheets, wide format flatted scanners can be used it. Okay, next one is nothing but the photo multiplier tube. This is also one of the best scanner, where you will have the very fast speed present in this one, that you try to call it as a photo multiplier tube. Prior to the advances in the field of sheet fed scanners, the drive scanners were extremely used for the scanning and all. Okay, next we will go for the raster GIS file format. The raster GIS file format will be represented in the form of either with the extension of JPEG, or whether the extension of image, or whether the extension of movie, or whether the extension of SWT. There are various types of extensions that are present in the form of a JPEG or JPX or JP2 image files or PRJ files and all. However, they wanted to, depends upon their requirement. Normally, the extension of that particular file has been created. Okay, these are all the various types of the ARDS imaging files are priority to this one. Thank you.